Assalamualaikum and good morning to all for B students. Today you're going to learn a new chapter, chapter 6, acid, base and salt. Okay, so let's look at the subtopics in chapter 6. Okay, there are 11 subtopics in chapter 6. 6.1 is role of water in showing acidic and alkaline properties. 6.2 pH value, 6.3 strength of acids and alkalis, 6.4 chemical properties of acids and alkalis, 6.5 concentration of aqueous solution, 6.6 standard solution. 6.7 neutralization, 6.8 salts, crystals and their uses in daily life, 6.9 preparation of salts, 6.10 effect of heat and salts, and 6.11 qualitative analysis. Okay, so for today's lesson, we will focus on 6.1, the role of water in showing acidic and alkaline properties. Okay, so these are the learning standard. Okay, at the end of the lesson, you should be able to define acid and alkali. Okay, state the meaning of basicity of an acid and investigate the role of water in showing acidic and alkaline properties through experiment. Okay, so the figure shows acidic and alkaline substance in daily life. Okay, so the first picture, okay, the kid asked the dad, okay, Dad, how can I make this corn shiny again? So the dad said, try scrubbing it with lime. Okay, so the lime represent the acid, okay, the acidic in a daily life. Okay, so the other picture, the boy asked, Mom, why do we need to brush our teeth every morning? So the mom answered, in order to neutralize the acid on our teeth. Okay, so um, the toothpaste, okay, the toothpaste represent the alkaline substances in daily life. Okay, based on the Arrhenius theory, acid is a chemical substance that ionizes in water to produce hydrogen ion H+. Okay, so this definition is very important. Okay, acid is a chemical substance that ionizes in water to produce hydrogen ion H+. So these are the examples. Okay, hydrochloric acid, okay, will ionize in water to produce hydrogen ion plus chloride ion. Okay, and nitric acid here will ionize in water and produce hydrogen ion H plus and nitrate ion. Okay, so the hydrogen ions produced will combine with the water molecules H2O to form hydrosonium ions H3O plus. Okay, the charge is positive here, alright. Okay, not negative, positive. Okay, so the figure shows the formation of hydrosonium ion H3O plus. Okay, so for example, hydrochloric acid here, okay, will ionize with water, okay, in water and produce hydrosonium ion. Okay, all right, so N plus and chloride ion. Okay, from H2O, the H plus combine here. Okay, look at the notes here. Although hydrosonium ions H3O plus are the actual ions existing in the aqueous solution that gives the acidic properties, to simplify explanation, we often use hydrogen ion to represent hydrosonium ions H3O plus. Okay, you look at the definition. It said produce hydrogen ion, right? Okay, actually it's hydrosonium ion. Okay, but we just simplify it to ion hydrogen. Okay, actually hydrosonium ion. Okay, that shows the acidic properties. Okay. Okay, so the figure 6.3 shows the classification of acids based on the basicity of the acids. Okay, so there are three parts. Okay, the first one is monoprotic acid. So example is hydrochloric acid, HCl, produces one hydrogen ion per acid molecule. Okay. The second one is diprotic acid. For example, sulfuric acid, okay, produces two hydrogen ions per acid molecule. Okay, the third one is triprotic acid. Okay, example, phosphoric acid, okay, produces three hydrogen ions per acid molecule. Okay. Okay, base is a substance that reacts with acid to produce salts and water only. Okay, now we're talking about base. Okay, so the definition here is very important. You must remember, base is a substance that reacts with acid to produce salt. Okay, garam, salt and water only, dan air. So for example, here, magnesium oxide, okay, reacts with sulfuric acid and produce salt and water. Okay, and here calcium hydroxide, okay, react with nitric acid, okay, produce salt and water. Okay, alright, so brain teaser here. Observe the chemical equation below, right? Magnesium react with hydrochloric acid, produce magnesium chloride and hydrogen gas. So you can see here, it's not water, it's hydrogen gas. Okay, so is magnesium a base? Why? So of course it is not. Okay, you can look at the product. Okay, there's no water here, so the answer is no. Okay, no. Magnesium reacts with hydrochloric acid to produce magnesium chloride and hydrogen gas, but not water. A base is a substance that reacts with an acid to produce salt and water only. Okay. Okay, a base that is soluble in water is called alkaline. Okay, so potassium hydroxide and sodium hydroxide are alkaline because they are soluble in water. Okay, so when sodium hydroxide pellets, okay, is dissolved in water, sodium ions and hydroxide ions that can move freely in water are produced. Okay, like this. This is the chemical equation. Okay. So the figure shows the dissociation of sodium hydroxide into ions that move freely in water. Okay, so dissociation means like separating, okay, the sodium hydroxide into ions, okay, that move freely in water, okay, which is sodium ions and hydroxide ions. Okay, alkali is a chemical substance that ionizes in water to produce hydroxide ions. Okay, so this definition is important. Okay, so remember, alkali is a chemical substance that ionizes in water to produce hydroxide ions. Okay, OH, a minus. Okay, like this. Okay, what will happen to ammonia molecule when ammonia gas is dissolved in water? Why is aqueous ammonia produce an alkali? Okay, so this is the formation of hydroxide ion from ammonia molecule. Okay, so it dissolve in water and produce ammonium ion. Okay, and hydroxide ion. Okay, so it is an alkali. Okay, it is an alkali. Okay, because the reaction is also called ionization. Okay, because it is ionization as simple molecules of ammonia and water react to form ions. Okay. Okay, so these are the fields that use acids, bases, and alkalis. Okay, for example, agriculture, industries, medicine, and food industry. Okay, we will do activity on this later. Okay. Okay, so the figure shows the role of water to show alkalinity. Okay, all right. So the girl asks the mom, why is the new soap taken out of its box not slippery? Okay, the mom answered, try to add some water and rub the soap. Okay, what do you feel now? It's slippery, mom. Okay, so the water shows the alkalinity. All right. Okay, earlier on, I have given you the link for the experiment. Okay, I hope you already watched the experiment. Okay, there are two experiments in the subtopic. Okay, so we will just go through this experiment. Okay, slide by slide. Okay, I hope you already watched, yeah, the experiment I gave you earlier on. So this one is the experiment to study the role of water in showing acidic properties. Okay, all right. So from the experiment, we know that Acids only show acidic properties in the presence of water. Okay, when an acid is dissolved in water, acid molecules will ionize to produce hydrogen ions, H+. So the presence of hydrogen ions, H+, allows the acid to show its acidic properties and change blue litmus paper to red. Okay, without water, acid only exists as molecules. Hydrogen ions are not present. Thus, the color of blue litmus paper remains unchanged. Okay, hydrogen ions are responsible for these acidic properties. Okay, sour taste, corrosive, has pH value less than 7, and change moist blue litmus paper to red. Okay, corrosive here, okay, means it's by chemically destroying the part oxidation or indirectly by causing inflammation. Okay, so it is a highly reactive substance that causes obvious damage to living tissue. Okay. Okay, so these are the second experiment, okay, to study the role of water in showing alkaline properties. Just now acidic, now alkaline. Okay, so same like before, okay. I've given you the link of experiment, okay. I hope you have watched it, okay. Now we just go through slide by slide, okay, and make sure you read the discussion in the slide, okay. Take your time to read it. Okay, so for the conclusion, alkalis only show alkaline properties in the presence of water. Okay, without water, hydroxide ions in sodium hydroxide pellet cannot move freely and still tight in its lattice structure. So the pellet of sodium hydroxide doesn't show alkaline properties. The red litmus paper cannot change color. When a pellet of sodium hydroxide is dissolved in water, hydroxide ions are produced and able to move freely. Thus, sodium hydroxide solution shows alkaline properties. Hence, the moist red litmus paper turns blue. Hydroxide ions are responsible for these alkaline properties. Okay, it tastes bitter and feels slippery, corrosive, has pH value more than 7, changes moist red litmus paper to blue. Okay, now we come to test yourself 6.1 from your textbook. Okay, so these are the questions. Okay, so I want you to do this exercise. Test yourself 6.1, number 1, 2, 3, and 3. Okay, okay, you try to do first. Okay, you do first, and then you can check your answer with the answer here. Okay, so please don't look at the answer yet. Okay, you try to do on your own first, and then you can check with the answer. Okay. Okay, after you have done the work, you can check the answer. Okay, so these are the answer. Okay, okay, that's all. Okay, so I hope you can do the exercise. Okay, and after you do and check your answer, snap a picture and send to me. Okay, thank you.